Hey, what's going on, my ASVAB party people? Anderson here, your ASVAB coach, and in this 2-hour video, we've got a recording for you. We've gone over mixed numbers, and there's some good questions that we're going to answer, like how do you add, subtract, multiply, and divide mixed numbers? But most importantly, how do you answer random questions like, what's the reciprocal of this mixed number? Like 1 3/4, take the reciprocal. These are some questions that we're going to answer. We're going to have plenty of practice, plenty of fun here to be had, so let's go ahead and let's watch the video. But before we begin, make sure to like and subscribe to this channel. Come on, guys. It's the easiest way for us to keep helping people like y'all. That way the world can keep going around. And if you like this recording, make sure to ask me about the All Access program. The description of all of that and all of the information is going to be in the description of this video. So make sure to check that out if you're interested in the program. But long story short, you get access to me to ask any questions, all the live classes and recordings, and thousands of extra practice problems. That way you can keep raising your confidence and your score. So without further ado, let's get to the action. Let's ace the ASVAB. Let's get started, gang. Let's go. So mixed numbers is what we're here to talk about today. But before we can actually talk about mixed numbers, we got to understand the different types of ways that you can present fractions. So over here, I got you all covered. We're going to be talking about proper fractions, improper fractions, and mixed numbers. So again, the point of today is to talk about those mixed numbers. And as a reminder, everybody, make sure to keep yourselves muted. That way we can go ahead and have a clean recording here. I'll do you all the favor of muting you now. But let's just talk about these 3 main points. So 1, proper fractions. Let's go and talk about these. So a proper fraction is literally just a fraction where it's not 1 or above. Like it's just a small number. And so all that means is the part is smaller than the whole. Everybody, which one is the part? The top or the bottom? I'm going to type it into the chat box. Which one is it? Is it the top or the bottom? When I say the part and the whole, which one is the part? Okay, love the participation. Love the participation. A lot of us are saying top there. There we go. Now let's ask ourselves, what's another way to say top? What's the formal way of saying top? What's the formal way? I see some of y'all typing way too fast to try to get me first. Yeah, numerator. That's right. It's going to be called the numerator. And the whole is called the denominator. The bottom is called the denominator. So when the top is smaller than the bottom, you have what's called a proper fraction. And this, you really don't need to know like the back of your hand. It's not really too important, but you do want to be able to talk about this at the very least. So the only difference between a proper fraction and an improper fraction, only difference is that an improper fraction is more than 1. It's 1 or above. So let's just take a look at some of these examples here. Just take a look at some of these examples just to kind of get an idea of what we're really feeling out. So a proper fraction, you can have 1/2. Let me use a highlighter here. You can have 1/2. You can have 3 out of 8. You can have 19 out of 20. So I hope you start noticing, look, the top is smaller than the bottom. If you were to go ahead and actually turn these into decimals, every single one of them would be less than 1. So again, that's a proper fraction. That's a proper fraction. And it keeps going forever. Now, let's go ahead and talk about improper. Now, an improper fraction, look, the part is greater than the whole. That's it. The part is greater than the whole. So, for example, let's just take a look at 3/2 over here. So, think about it like this. Think about it like this. If I were to tell you to run half a mile, is there anything wrong with me saying that? If I said, hey, run half a mile, right? Unless you just hate running, then there's a problem. But besides that, I mean, like there's no real issue, right? If I say, hey, run half a mile, that's half a mile, it's whatever. But what if I said, like, hey, Smith, run 3/2 of a mile? Does that sound like it rolls off the tongue? Do I sound smart saying that? No, right? No, that doesn't sound very, that doesn't sound like it flows. Like if I say 3/2 of a mile, but here's the thing. Another number that means the exact same thing as 3/2 of a mile is, hey, Smith, go run 1.5 miles or 1.5 miles. Does that sound better to anybody? Let me know in that chat box. Does that sound better to anybody? If I say 1.5 miles versus 3/2 miles, right? I would assume so, right? If you're in the chat box, there you go, right? I would assume so. And so that's the point of the whole idea in terms of mixed numbers. So I got to make sure you understand what the hell this idea is all about, because I can tell you right now, man, it is so hard to get behind something in math that doesn't actually make intuitive sense. The reason that mixed numbers exist is just to help us talk about improper fractions a little more fluidly. That's it. That's it. So there we have it. Improper fractions, again, where the top is larger than the bottom, or the numerator is bigger than the denominator, or a fraction that's more than one that should be written as a whole number and a fraction. And what that's called is a mixed number. That's what that's called. Again, a mixed number, all it is just a way to write an improper fraction in a more understandable form. That's all it's meant to be. And so when we take a look at the 3/2, again, a better way to write it is just 1.5. It's just 1.5. Now, here are other examples. These don't really correspond to anything, so don't worry about it. But these are all different examples. And if you notice, every single mixed number here, it includes a whole number and a fraction. That's why it's called mixed. Whole number plus a proper fraction. And it's all there to give you a feel for that number. That's it. That's it. So moving forward here, the question here that a lot of us may be asking is, well, okay, great. I've known this. I know that proper fractions exist, improper fractions, mixed numbers. But the question is, how do you convert? How do you convert between improper fractions and mixed numbers? So we're going to go through both methods. One, I'm going to show you how to go from improper to mixed. Then over here, I'm going to show you how to go from mixed to improper. So let's start over here, get our job done, understand, the ins and outs, and then we're going to practice a little bit. All right. So 3 steps here, 3 steps. And I'm going to show you with this example right here. So number 1 is you're going to divide the numerator by the denominator, and that's going to give you that whole number. Now, let me ask you, everybody, when you divide whole numbers, is it always going to be a perfect division? Like, are you always going to have a perfect answer? Nah, right? And we're using the chat box right now. I muted the mics right now because, again, I need the recording to be good for everybody else who's going to be watching after. Right? No. Not every division is going to be perfect. Like if I divide, 10 by 3, that's not going to be perfect because you can go up to 9, but then you have a remainder. So that's what's going to happen here. When you are turning from an improper fraction to a mixed number, again, you're going to divide the numerator by the denominator, divide the top by the bottom. But in case it's not perfect, the remainder is what's left with the fraction. The remainder is what's left. And you're going to keep the denominator the same because your whole, the denominator, the out of, it's not going to change. It's not going to change. So if I have a box of pizza and it's cut into 8 slices, it's always going to be out of 8 slices every single time. You can eat a slice, you can add another box, you can do whatever. Every box is 8 slices. So think about it that way. If I'm looking at it like this, I basically have boxes of pizza where each box is cut into 4 slices. Now, if I have more than 4 slices, I have more than 1 box. If I got less than 4 slices, I have less than a box. And we're going to talk about this again. We're going to feel this out a little more, but let's go ahead and go through it here. And let's go through the process. So go ahead. I want to see everybody type it out in the chat box. What's step number 1? Turning improper to a mixed number. What are we going to do? Go. Come on. Divide. Okay, cool. Divide. Sounds good. Let's go into it. Everybody, how many times does 4 go into 19? How many times? Right, it's going to go into it 4 times. 4 goes into 19 4 times. So you can think about it like this. If you wanted to think about it with long division, again, this is a way that I wouldn't recommend doing on the ASVAB because you're timed, but just to see it and feel it out, what you're going to do is you're going to say, hey, I'm going to take 4 and I'm going to divide that into the 19. So we know that 4 goes into 19 4 times. We'll subtract what? What are we subtracting? Correct. We're subtracting 16. 4 times 4, 16. Yep, we got that. We're good. And we're going to get 3 left over. So notice how that remainder of 3 can't really do anything with it. And so here's what's going to happen. We know We know that 4 goes into 19 4 times. So that's how many boxes of pizza we can pull out. And so that's going to give us 4, but with the remainder still there. With the remainder still there. And so that's how you would turn an improper fraction into a mixed number. Step 1, divide. How many times does 4 go into 19? Oh, 4 times. Cool. Well, that wasn't perfect, though. I got 3 left over, and you'll just leave the remainder in there. That's it. That's it. That's it. And so someone asked directly here, hey, why don't you actually go ahead and put a 0 here and keep dropping? Because the point here is to convert an improper fraction into a mixed number, not converting to a decimal. Good question, though. That's a great question. That's a good question, though. And so there's a brief example, again, of how to turn an improper into a mixed number. But let's go ahead and reverse the order here so that way we can look forward and get more practice. So let's talk about this. How to convert between improper and mixed. So let's go ahead and go from a mixed to improper. So everybody, yes or no, to you, does it sound like we're working backwards? Yes or no? Right? We're doing it backwards. We're going the opposite direction. So we're going to do the opposite steps. So in going from a improper to mixed, we divided. So here we're going to multiply. Now let's ask ourselves what we're going to multiply. Everybody, this 3 right here, this represents how many wholes you have. So how many of these you have. So if we have 3 of these whole numbers, 3 of these 4s, exactly, we're going to multiply the 3 times the 4. You're going to multiply the whole number by the whole. I think that makes kind of sense, right? It makes a little bit of sense. We are going to multiply the whole number by the whole. And so let's go ahead and check this out, my party people. Let me go ahead and make it a little bigger so that way we can still see the notes. So again, looking at this first step, multiply the whole number by the denominator. So we're going to take 3 multiplied by 4. That's going to clearly give us what? Everybody help me out. That's going to give us 12. That's correct. And then what you're going to do here is you're going to go ahead and add the result to the numerator. Because again, that whole number, that 3 right there, that represents how many wholes you have. And you have essentially 4 of those wholes, or 3 of those wholes that each are 4. So 3 times 4 gives you 12. Add it back to the top. Everybody, 12 plus 3 gives me what? Right. That's going to give me 15. And we're good. We're set. And so what this is going to turn into is 15, but we're keeping that denominator of 4. So notice in either instance, whether we're converting from mixed to improper, improper to mixed, doesn't matter. You're keeping the denominator the same in either case. Okay, either case. So Carlitos, just wait, man. I got you. You know how these classes start? We have to make sure we get the basics down, because once we get into those harder problems, we can then resort back to those fundamentals to keep ourselves going. And so there it is, my party people. I'll give you guys a chance to take a screenshot here. Go ahead, take a screenshot. I'll give you, 5 more seconds here. And time. All right. So this is going to be the final one, I believe. Yeah, this is the final one before we really get into the practice. So take a screenshot of this again. This last one here. Take a screenshot, because I'm going to review these notes. And honestly, once you actually understand what's really going on, it's going to make your life a lot easier. It's going to make your life a lot easier. So adding and subtracting fractions, one thing that we always need to know is that we need the same denominator. One thing about multiplying fractions, well, you're simply going to multiply the numerators with the numerators, denominators with the denominators, and then simplify. But let me go ahead and refresh you on this one. Did anybody here know that when it comes to multiplying fractions, did anybody here know that you can simplify before you multiply? Did anybody here know that? you can simplify before you multiply. You've been to my classes before, that should be an automatic yes if you've been to a fractions class before. If not, don't worry, because I'm going to show you. All right, no worries there. All right, cool. And now let's take a look at dividing fractions. So when it comes to dividing, KCF. So KFC, a lot of y'all like to eat there. I used to like to eat there until I learned about the heart attacks. But we're looking at KCF. Keep, change, flip. So let me go and highlight this for you to make your life a lot easier. So keep the first fraction the same, change to multiplication, and then flip the second fraction. KCF. When you're dividing fractions, simple strategy there. Keep, change, flip, and we're moving forward. Now, I'm going to give you examples of all these. Don't worry. We're going to get into examples of all these. But before we get into all that, we're going to talk about this little thing called reciprocals. This is honestly going to be the one thing that you really want to pay attention to today, because we're going to look at some ASVAB questions that, honestly, if you knew this, easy. But if you don't, you're sitting there like, oh, sweet Lord, baby Jesus, Chipotle, help me. I don't know what to do. Oh, my God. You know, all the feelings we want to avoid. So finding the reciprocal of a fraction, what you're doing here is simply flipping the numerator and the denominator. That's it. That is literally it. When you are taking the reciprocal, you're just flipping the numerator and denominator. And we'll talk about, we'll definitely talk about the whole idea of working with mixed numbers there with that. I got you. So with that, let's go ahead here. Let's talk about a little guided warm-up. So I want to give you guys a chance here, give you guys a chance to try this out. So I'm going to give y'all here a second. Let me get that timer up. All right. So this is an example of a problem over here. This is an example of a problem where they're not telling you what to do, but you can definitely figure out what to do, though. They're not explicitly telling you, yo, add this, do that. No, they're just asking you, hey, which one of these is the same as that? Okay. Which one of these is the same as that? Sounds good. So everybody, what form is 31 over 5? What is that called again? What's that called again? Thank you for being specific there. Yeah, improper fraction. That's an improper fraction. So let's go, just go and call it out there. Call it for what it is. That's an improper fraction. The reason that we know it's an improper fraction is because the numerator is bigger than the denominator. Cool. Now, when we take a look at the answer choices, everybody, all of the answer choices are what? All of the answer choices are mixed numbers. That's right. Every single one of the answer choices is a mixed number. So through inferencing here, is it okay and safe to say that what we're trying to do here is turn this improper fraction into a mixed number? Yes or no? Cool. So first and foremost, we understand this then. What we have to do here, step number one, what do we want? We want to change 31 over 5. We got to change that into a mixed number. So let's go ahead and remind ourselves on how we do that. So in our notes, we should have read, okay, to turn an improper fraction into a mixed number, we'll go ahead and divide. And then whatever's left over, we'll keep it in the numerator. Cool. Sounds good. Let's go ahead and get to it then. So everybody, how many times does 31 get divided by 5? How many times can 5 go into 31? How many times? So I see a lot of people here saying 5 and 6, and there we go. 6 is the answer here. So let's go ahead and actually just show it just to make sure that nobody's going crazy. So 5 going into 31. Well, 5 goes into 31 6 times because 5 times 6 is 30. And so then we're going to have the 1 left over. And that 1 is going to stay in the fraction. That 1 couldn't get out. It couldn't get out. We know that the 6 can come out because 5 goes into 31 6 times. But there's that remainder of 1, that extra 1 that just can't get out. And so it has to stay locked up where it was. So 31 over 5, we can turn that into. And we see that, hey, we got 6 right there. And then we're going to have a fraction. The remainder here, that stays in the numerator. That stays right there. 1, let me draw a better one. Out of, what's the denominator going to be, everybody? Is it going to be 6, 5, 2? What is it going to be? That's right. It's going to stay 5. So again, here when it comes to dealing with mixed numbers, guys, it's really going to be following that procedure, sticking to it, and trusting the process. Obviously, as time goes by, we'll get better and faster. But as long as you understand the process first, then we can work on speed later. But let's just focus on the process first. Again, getting one problem better at a time. And so with that said, we have 6 1/5, and that's going to confirm our answer as C. Going to confirm the answer as C. And so on a scale of 1 to 10, how are we feeling right now? Feeling all right? Yeah, and even if you got it wrong, even if you made a mistake, do you feel like you can identify what that mistake was and move forward? Like, that's the most important part. Again, I'm not here asking for perfection. I just want to know that we're getting better. Okay, great. So I see a lot of y'all saying 10s and 9s and 8s. Okay, great. Happy for you. Happy you're confident. I'm going to let you try one out now. So I'm going to give you a minute, 15 seconds here. We shouldn't need any more than that. I'm going to give you a minute, 15 seconds. And when you're done, remember, don't reveal your answer. Do not reveal your answer. Just type ready when you're ready. And that's it. So 3, 2, 1, minute, 15 seconds. Try it out. So here we go. The problem states, I'm going to go and zoom in a little bit here so we can see more of it. All right, cool. So it says turn 48 over 9 into a mixed number. Okay, so we're checking this out. And I'm really wondering why a lot of people said that they were confident, but nobody here called out the BS. No, not a lot of people here called out the BS. Everybody who is 100% confident with this, what's wrong with this? Saying no answer, they're wrong. Yeah, okay. Okay, let's find out. Let's find out. So here we go. Turn it into a mixed number. Sounds good. Here we go. 48 over 9. All right. So looking back at our notes, it says divide the numerator by the denominator. Everybody, how many times does 9 go into 48? Right, it's going to go in there 5 times. Exactly. It's going to go in there 5 times. Okay. So right at the gate, if 9 goes into 48 5 times, which of these answers can we automatically eliminate? Which one? Which one can we eliminate? That's right. We can eliminate A. Because if we got 5 as the whole number, yeah, A doesn't make too much sense. So this is going to be equal to 5. And then with that remaining fraction, when we take away, everybody, what's 9 times 5 again? Quick, chat box, go. Yeah, it's going to be 45. All right. And we're going to get 3 as the remainder. So a lot of us may be looking at this saying, okay, we got 5 and 3 9ths. I'm looking up and down. I don't see this. And so clearly looks like the answer isn't there. But everybody, what's that S word that a lot of us tend to forget sometimes that we need to do? Yeah, we got to simplify. We got to simplify. And so let me just give you a quick crash course reminder on what simplifying looks like. So if we zoom on in, let me go ahead and grab the 5 and 3 9ths. If we zoom on in, let's remind ourselves on how to simplify fractions. Everybody, finish the sentence. With fractions, whatever you do to the top, you must do to the bottom. Exactly. When it comes to simplifying fractions, whatever you do to the top, you must do the bottom and vice versa. So let's make sure to write that down because I got a lot of people here. I saw a lot of people here in the chat box getting messed up over this. So let's talk about this real quick. So when simplifying, let me just zoom out a little more here. Simplifying. So basically, whatever you do to the top, you must do to the bottom. Write that down. You must do to the bottom. Must. I'm telling you, by following this, you're going to save yourself a lot of trouble here. So let's go ahead and tackle this. Everybody, when you look at 3 and 9, what can both of those numbers be divided by? For sure, 3. We can divide them both by 3. So let's go ahead and take care of business here. If I divide the 3 by 3, I got to divide the 9 by 3. Got to divide it. Remember, when you're reducing or simplifying or whatever you want to call it, you're not changing the actual value of that fraction. All you're doing is just changing the way it looks, simplifying it. Because everybody, if I were to say 50 out of 100, is that not the same thing as half? Yes or no? Is 50 out of 100 not the same thing as half? Right, exactly. So why would I go to my manager and be like, hey, we got 50 out of the 100 trucks ready to go. We have, 450 out of the 900 trucks ready. Why not just say half? Hey, boss, half the trucks are ready. Right? Simplifying. That's all it means. Simplifying. That way we can talk about things easier. That's it. And so when we divide both the numerator and denominator by 3, what we're going to end up getting is 3 divided by 3 is 1. 9 divided by 3 is 3. And so we're going to get 5 and 1/3, which means that the answer actually is there, and it's going to be B. It's going to be B. So with that said, was my acting good? Did I get anybody? Got you, Joe Marie? Hey, right on. So I do this all the time. If you're new to my classes, just know that one thing that I do not do is give you everything. I don't give you the keys to the house. I help you discover things. I help you learn things. And am I going to piss you off a little bit? Yeah, I kind of like it. But at the end of the day, you are going to grow. You are going to make sure that you make the progress that you need to make. So with that said, does anybody here have any questions at all? Anything that I need to reiterate? Anything that I can touch on again before we move to the next example? Cool. No questions? Okay, well, is it easier to simplify first or after? So with a problem like this, though, when you're looking at 48 over 9, if you know that both 48 and 9 are divisible by 3, yeah, you can simplify first. It could definitely make your life easier down the road, but you have to notice those simplifications right away. If you can notice it right away that 48 and 9 are both divisible by 3, do your work, do your thing, and then you simplify after. It is a little easier. So with that said, let's take a look at this next example here. So we're changing directions now. We're looking at this and we're asking, hey, which of the following is 3 2/5? Which of the following is 3 2/5 as an improper fraction? So if you want to go ahead and start trying this on your own, go ahead. But I'm going to walk you through in a quick moment after I answer this question from Natasha. So Natasha asks, hey, when you multiply and divide fractions, do you always simplify? Yes. If you can simplify, simplify. Absolutely. And even when adding and subtracting, at the end of the day, if you can simplify and reduce, you should. You should. Because chances are the answer is going to be simplified. So, great question, Natasha. Let's go ahead and try this out here. So we have 3 2/5 as a mixed number. We want to turn it into an improper. Let's go ahead and do our work, my party people. So let me just zoom in a little bit on the answers to make those clear as day. 3 2/5. All right, everybody. So we're reversing the order now. Instead of dividing for going to improper to mixed, what do we need to do to go from mixed to improper? Multiply then add, exactly. Multiply then add. So if you want to make your life a little easier in terms of thinking about it, I'll present the notes in a simplified way at the end of this. But here, we're just going to go ahead and multiply and then add. So here's what we do. We're going to take the 3 and we're going to multiply it with the 5. Everybody, 3 multiplied by 5 is? Correct. That's going to be 15. Absolutely. It's going to be 15. And then what we're going to do with that 15 is we're going to add it back to the numerator. So we're going to multiply and then add it back. And that's it. So everybody, 15 plus 2, that will give us 17. Absolutely. And what happens to the 5 again? What happens to that 5? What happens to it? Right, it stays there. You keep it the same. Remember, at the end of the day, what you're doing here, this whole right here at the bottom, that whole number, all that's talking about, everybody, that's just saying, hey, this is how many slices my pizza box can hold. This pizza box holds 5 slices. I don't know who in their right mind would ever order a box of pizza that's cut into 5 slices. I don't know how they would do that. But the fact of the matter is that's how many slices this box can hold. And so if we have 17 slices, we definitely have more than one box. But there it is, 17 over 5. That's what we got. So let me just make sure you really, now that we've practiced a little bit, you have the simplified version of these notes now. So thank you for reminding me. I forgot who that was there. But watch this. Improper fraction to mixed number. What you're going to do here, gang, you're just going to go ahead for improper to mixed. You're going to divide and subtract. You're going to divide and subtract. For mixed to improper, it's the exact opposite. It is the exact opposite. And what you're going to do here is you're simply going to multiply and add. So I hope you notice, like, look, these processes are the exact opposites of each other. And they are on paper, algebraically, numerically. It is the exact opposite. And so if it makes your life a little easier, go ahead, write that down. And if you like the way that I presented it, simply now, after giving you the full notes, let me know if you like it that way. Because I already know when I'm presenting shortcuts, if you don't have an understanding of how the original method works, then it gets a little tough. So let me know if you like me presenting the shortcut after we've explored the actual method. Cool. Sounds good. Sounds good. Sounds good. All right. So with that said, 17 over 5 is the answer. And that's why B is it. All righty. So what we're going to do now, I'm going to give you another problem. I'm not going to tell you what it's about. I'm going to give you 1 minute to try it out. And we're going to go ahead and move forward. So Alonzo asks, hey, how can you tell if it's improper or mixed number? So remember, a mixed number, it always has a whole number in front of it. It's mixed. You got a number and a fraction. Number and a fraction. You can tell that it's an improper fraction when you have more than the whole. Like if I said 22 out of 5, like, yeah, that doesn't make too much sense. You know, you can say like, oh, I got 22 out of $5 in my pocket. What? Why not just say $4.40? Like, it's that simple, right? So that's the idea there. Mixed number, mix between a number and a fraction. Improper fraction, it's improper. You got more than what you have. You got more than what you need, exactly. You got more than what you need. 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 Improper. You're hoarding. Yeah, no worries. So here we go. 3, 2, 1. Let's go. Try it out. 1 minute, starting now. Remember to type ready when you're ready. Here we go. What is 13 4/7 as an improper fraction? So this problem clearly gives us the directions. We're saying, hey, 13 4/7 as an improper fraction. So just got to turn yourself into your head here. Ask yourself, okay, am I dividing and subtracting or multiplying and adding? Which one is it, gang? Am I dividing and subtracting or multiplying and adding? Which one? Which one? Which one? Which one? Is Christian the only one? Ah, there we go. Yeah, ring it in there, ring it in there, ring it in there. We are multiplying and adding. We are multiplying and adding. Let's go. So let's get to it here. We got 13 and we got 4/7. We're over here. And so what we're going to do, step 1, we are going to multiply right here. All right. Was anybody here able to do 13 times 7 in their heads? Who here did it on paper? Shout yourself out. Paper or mental? Which way did you do? Paper, 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 paper. Some mental, some mental. My students, obviously, yeah. Paper, 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 paper. Okay, cool. So everybody, put your pencils down for a second. Let me show you how to do this thing called mental mathematics. All right. So honestly, mental math is already known by you. Like every single person in this room, I don't care who you are, you can be like, oh, I don't know how to do mental math. Yeah, you do know how to do mental math. Let me show you why. Everybody, isn't 13 the same thing as 10 and 3? True or false? Isn't 13 the same thing as 10 and 3? Right? I think that's an obvious question. That was almost rhetorical. Yeah, 13 is the same thing as 10 and 3. So in my head, if I'm doing 13 times 7, isn't it easier to just do 10 times 7 and 3 times 7? Everybody, what's 10 times 7? Ain't that easy? What's 10 times 7? Okay, that's 70. Okay, and what's 3 times 7, everybody? Oh, 21. Okay, cool. Everybody, what's 70 and 21 plus? What happens if we add them together? 91. 91. So this is called split and glue. All you're doing is splitting the number up into the tens place and the ones place. So 13, 10, and 3. Helps you deal with easier numbers. That way, when you're multiplying, instead of doing one big, ugly step, you can do 2 easier steps and still get the same result in a faster time than it would by actually doing this. Oh, let's go ahead and do 13 times 7. We can be done by the time you're writing that out. By the time you're done writing this, we can be done. And so, yeah, you'll do it. 3 times 7, 1, carry the 2. Then you got the 1 times 7 plus the 2 is 9. We don't need all that. Don't need all that. You can use the split and glue strategy. And if you're in the all access pass, there are literally 15 classes on this that you can watch whenever, called split and glue. This works for multiplication, division, addition, subtraction. Just shouting that out there. So we have 91 there. What are we going to do with that 91 now? What are we going to do with that 91? Correct. We're going to add that 4. Exactly. We're going to add it back to the 4. So if we add 91 and 4, rhetorically, that is 95. Not going to make you answer that. And so the answer is going to be 95 over 13, right? 95 over 13. Is that correct? Yeah, wasn't that chat box blown up? No, not going to be over 13. Remember, always keep the denominator the same. And that denominator was 7. And so we will keep 7. 95 over 7 is the answer. And that's why A is it. And there it is. That is A. That's all good. It's all good, Evan. And so there we are. Now, moving forward, let's talk about a problem that is going to annoy some of y'all. All right, let's go ahead and lean in. I'm looking at some of y'all's faces on the camera like, oh, we're doing this now. Yes, we are. But trust me, I'm telling you right now, if we can learn how to do this, I'm telling you right now, you're going to be leaving this class like, I know I'm going to get that right next time. So watch this. What is the reciprocal of 1 and 2/3? So I want y'all to be able to appreciate the math that we're about to do. So I'm going to give y'all a minute to try this out under pressure. Just try it out. Again, do what you can. Do what you can. Type ready when you're ready, but go. All right, so let's get to it here. All right, so pay attention to this. And before I even begin, yes or no, have you ever been frustrated by a problem like this practicing for the ASVAB? Yes or no? And so for anybody here who hasn't taken the ASVAB yet, this problem right here could very well pop up on your podcast. Not the exact numbers, but the exact process. So before I even continue, anybody here who is memorizing questions and hoping that they're on the test, stop doing that. Stop doing that. That's not how this works. Because the thing is, the moment that they change the numbers up, you're screwed. So you might as well learn the why instead of memorizing the what. Again, that's just my quick PSA on that. So let's get to it. What's the reciprocal of 1 and 2/3? All right, everybody, define that term for me. What does reciprocal mean again? What does it mean? Flip it. That's right. Flip the fraction. That's right. Flip the fraction. So what, again, the reciprocal means flip the fraction. So if we're looking at something like, A over B, again, I'm just putting some, some letters in there to kind of make a little sense here. You're literally going to flip it, and that's going to turn into B over A. That's it. But what's the problem here? Why can't we just flip this and turn this into 1 3/2 and then say that A is the answer and call it a day? Like, what's stopping us from doing that? Right. It's a mixed number. It's a mixed fraction. We can't do that. We can't do that. We actually are going to have to turn that mixed number into a what first? We got to turn it into an improper fraction first. That's right. And that's it. So a problem like this, I'm telling you right now, a problem like this, if you know what needs to be done, you can look at any problem. I don't care what numbers are up there. You're fine. You're good. Ain't nothing going to stop you. Nothing. So watch this. This right here, wrong way to do it. No, 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 no. Not going to be A. We're going to go ahead here. We are going to go ahead here and write 1 2/3. First step is turn it into a mixed number. Or excuse me, turn into an improper fraction. My bad. Turn into an improper fraction. And then step 2, then flip it. Then flip. So let's go. 1 2/3. Let's go. Everybody, follow me. 1 multiplied by 3 gives me sounds good. And then from there, once we get that 1 times 3 being 3, we will do what with the 3? Add it with the... That's correct. That is correct. That is correct. So that's going to turn this into 3 plus 2 gives me that 5. And we still keep that denominator the same. So we have 5/3 so far. Now, here's what's going to happen. A lot of people may look at that and be like, oh, I got 5/3 and I see 5/3 in the answer choices. Anybody here ever gotten tricked by a problem where you got the answer, quote unquote, while you're trying to find the answer? And then you're like, oh, there's the answer. Nope, not going to happen. We're not getting tricked today. Our job isn't done. We now have to flip it. And so 5 over 3, that's going to turn into 3 over 5. And that is going to be our answer. It's going to be D. So anybody here feeling like, yo, this is possible? I can actually do this. Hey, that's what's up. I'm telling y'all, man. I'm telling y'all. When it comes to any topic on the ASVAB, it is a matter of 1, what are the fundamentals? Like, what are the little things that I need to know in order to be successful here? And then 2, let's apply those fundamentals, work through it, taking our time. And then once we actually have a handle on it, then we can worry about speed and calculating quickly and mental math and all that crazy stuff. But there's no point in being able to calculate quickly if you don't even know what you're supposed to multiply or what you're supposed to add. No point. So let's focus on doing the little things right to let the big thing take care of itself. And so there's D. There's the answer. I'm going to give y'all another problem here. I'm not going to tell you what to do, how to do it. I'm just going to set my timer with 1 minute, 15 seconds, and I'm going to give you the opportunity to try this out. So 3, 2, 1, let's go. Let's check it out here. So the problem asks us to figure out what the reciprocal of 8 4/9 is. All right. So for anybody here who's coming in a little later, I got to make sure you understand what's going on here. Everybody, if I were to go ahead and say, oh, take the reciprocal, that means flip. So I'm going to go ahead and take the 8 4/9 and turn that into 8 9/4. Is that correct or incorrect? Immediately. Yes or no? Yeah, it's going to be no. It's going to be a no. Because remember, to take the reciprocal, you will have to flip the entire fraction. When you have a mixed number, you're not seeing the entire fraction. You're seeing it in bits and chunks. So what we have to do here is turn that 8 4/9, turn that into an improper fraction first, and then flip. So that is incorrect. It's not going to be A. Step one needs to be, again, write it as a fraction, an improper one. So write as an improper fraction. And then we're going to flip. This is one of the easiest problems to mess up in the ASVAB. And we got to make sure that we don't get fooled. So then take the reciprocal, which means flip. All right, so let's take care of business here. We have 8 4/9. Let's go ahead and take care of business over here. We're going to take the 8 and the 9. We are going to multiply those right there. Everybody, 8 times 9 gives me 72. Got to know that, got to know that, got to know that. And then once we have that 72, what are we going to do with it? Exactly. So remember, as an improper fraction, A, we're going to multiply. Then B, we're going to add. Multiply, then add. To go from mixed to improper, multiply and add. So what we have here, we got 72. We found that multiplication. Now we're going to add it with the 4. 72 plus 4 gives us that 76. And so we're going to write this as, I'm going to use purple over here. We're going to have 76 over 9. That's exactly what we're going to have. And so with that said, now we are able to flip. So we're going to take that 76 over 9. Then we're going to flip that, which is going to give us 9 over 76, making D the correct answer. So before we continue, what I want everybody to do here, because we have practice time coming up next, I'm going to leave this up for the next couple of moments here to give you an opportunity to screenshot if you'd like to. But before we move on, I really want to emphasize the importance of talking about what you're doing. Again, there's no way to build confidence if you're not actually able to work with what you're doing fluidly. And what I mean by that is, can you do it? Can you talk about it? Can you do it while you're timed? Can you look at it from different situations? Do you know more than one way to do it? And that's why talking about it's so important. It helps you really come to grips with what you're doing. So before we get into this practice phase, we're going to get 1:30 seconds per page. We'll review each one. Remember to ask questions. But what I want everybody here to do before we get going in here and continuing, I want you to answer this question. What is one thing that before this class you didn't know or really needed help on that up to this point you feel like you've gotten the answer to? So go ahead. What's one thing that before this class you were like, I actually wasn't too sure on that, and now I got it? But be specific. All of this. I was expecting that, and I should have made the question a little easier. But solving fractions, the setup, what fraction to multiply, what fractions to divide, converting from mixed to improper, the mental math trick, Naya. I enjoyed that one too. Again, splitting and gluing, very, very useful tool. The reciprocal, mental math, reciprocal. Okay, cool. And keep going there. Because look, at the end of the day, gang, I'm telling you right now, I know it's going to sound annoying. I know it's going to sound like I'm wasting time. But if you can talk about it, you are on your way to mastering it. Seriously. Because the thing is, at the end of the day, most people hate what they don't understand. Like, it's true for everything. So with that said, we're moving forward here. We got 1:30 seconds per question. Obviously, that's going to be a little longer than I would like for the first couple of pages at least. But later on, I'm going to introduce adding, subtracting, multiplying, and dividing. And we're going to tackle that together. But for right now, let's just concern ourselves with similar problems. 1:30 seconds. 3, 2, 1. Let's go. And I'll continue looking through the chat here. So let's go ahead and get to work, man. Let's get to it. So what is the reciprocal of 3 2/3? Okay. What's the reciprocal of 3 2/3? So again, everybody, what's the one word we can use that starts with an F for reciprocal? Name it. That's right. Flipperoo. We're going to flip it. But again, before you can flip it, we got to make sure we have a fraction, just a fraction. We can't do it when it's mixed. We have to have a pure fraction here. So what we're going to do is we're going to start off by taking that 3 2/3, turning that thing into an improper fraction. So remember that the work that we're going to do here is we multiply the whole number by the denominator. So in that case, 3 multiplied by 3 gives us 9. And from there, we add it back with the numerator. And so 9 plus 2 is going to give us 11. And so now we have 11. And that's going to be still over 3. So it's this 3 right here that we're keeping the same, everybody. Just want to make sure that everybody's aware of that. That is the 3 that we're keeping the same. And then from there, what we're going to do is, hey, now we can flip. That's right, Mike. Now we can flip. And that's what we're going to do here. So flipperoo. Now we can take the reciprocal. Again, just flip. And that's going to give us 3 over 11. And there it is. That's how we get the answer, 3 over 11, which is going to be B. And we're all set. Now it's all set. And there it is. Now I see some people asking, or I think I saw someone asking, is this by itself an ASVAB question? Rashid? Yeah. Yeah. Plenty of people have seen it. Plenty of people have seen it. Got to make sure you know. Got to make sure you know. And so with that, any questions before we move on to the next one? I'm excited to dive into the next one here. All right, 3, 2, 1. Let's go. What's the reciprocal of 2 over 15 starting now? Let's see who knows how to handle this one. Let's go. Come on. So this is a perfect example of, hey, I just saw a problem that I didn't get the exact steps to do from the very beginning, right? You know, we're looking at this and we recognize the word reciprocal, but typically when we see this, we're so used to seeing a mixed number there and we got to go ahead and do our thing and blah, 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 blah. So was anybody here? Yes or no? In the chat box, let me know. Anybody here look at this and was like, yeah, we just had to turn it into an improper. Did anybody here do that? Did anybody here do that? We just got to turn it into an improper. Yeah, I would expect a few of us would have got there. So let's go ahead and understand really what we're doing. Okay. It says take the reciprocal. And everybody, true or false? To take the reciprocal, we need to have a pure fraction. Improper or proper, doesn't matter. We need a pure fraction. Yes or no? Okay, great. I'm glad that we understand the beginnings of this. That's a fundamental piece here. To take the reciprocal, we need a proper or improper fraction. We just need a fraction. We need a pure fraction. Do we have a pure fraction? Yes or no? Everybody hit me in the chat box. Do we have a pure fraction there when it comes to 2 out of 15? Is that a pure fraction? Perfect. Right on. Sounds good. Cool. If it's proper, then let's go ahead and take that 2 out of 15. Apply the reciprocal. And let's see where it leads us. So 2 over 15 becomes 15 over 2. And is 15 over 2 explicitly listed as an answer choice? Yes or no? Okay, my party people. So let's go ahead and use some deductive reasoning here. If I did what I was supposed to do and the answer isn't there, but I noticed that A, C, and D are written as mixed numbers, and I got an improper fraction over here. Everybody, let's go ahead and put 2 and 2 together. What do we got to do? What do we have to do? What do we have to do with that 15 over 2? What do we have to do? Okay, y'all are telling me the process. There we go. Change into a mixed number. That's the result I want you to talk about. We have to turn this into a mixed number now. Again, purely by observation. You look at your answer choices, and you're looking at your answer choices, and you're saying, yeah, those are all mixed numbers. So because all of my answers are mixed numbers, we're going to have to change this into a mixed number. So do you see that, gang? Like, it's not like, oh, I automatically turn it into a mixed number. No, I'm turning it into a mixed number because the answers are mixed numbers. Yes or no? Does that make sense, everybody? Before I continue, does that make sense? Like, you're basically analyzing the playing field and saying, oh, all of the answers are in that form. Well, then let me make sure I put it in that form. That's it. That's it. Like you're analyzing the playing field here. So change to a mixed number. And so everybody, what were the two steps for mixed number? Because for improper, or for a mixed to improper, that was multiply and add. So from improper to mixed, that was divide and subtract. That's right. So let me actually not use that. Divide and subtract. Okay. And so with that, cool. Everybody, how many times does 2 go into 15? How many times does 2 go into 15? 7 times, with the remainder of what? That's right. Remainder of 1. That's my remainder right there. I'm going to take that 1, leave it up top, 7.5. My answer is D. And we're good. And we're good. So if you were one of the folks that were confused in the beginning of this problem, do you, yes or no, understand why this was actually a much simpler problem than you might have thought? Cool. I love the excitement, guys. I really do. I love it. I love it. So with that said, let's go and keep moving here. Because what we got next is, we're going to get away from the whole like reciprocal idea here and things like that. Now we're going to get into the nitty gritty. So we're going to start getting into fraction operations. So adding, subtracting, multiplying, and dividing. We're going to get into it now. Okay. So again, we're not doing reciprocals right now. We're going to move into fraction operations. Now, if you forgot how to, change the denominators and all that good stuff, don't worry. I got your back. I got you. We're going to go through this. Now, what you're going to see here, you're going to see 2 problems on the screen now. You're going to see 2 problems. So what I'm going to ask you to do is pick one and do it. If you can get both of them done in a minute and a half, props. Absolute props for sure. But if you can't, I want you to at least try to get one of them done. So with that said, 3, 2, 1, go. With that said, let's take a look at both of these. So the first one reads 3 2/3 plus 2 2/3. The second one, 1/2 plus 3 1/3. So just by opinion, which of these do you guys interpret as easier? Which one looks easier to you? Number 1 or 2? Which one looks easier? Okay, I'm seeing already a trend here. I see a lot of people saying that number 1 looks a lot easier. Why would you say that? Why does number 1 look easier to you? Let's talk about it. If 1 looks easier to you, why? If 2 looks easier to you, why? I love that. I love the detail there. Yeah, we have the same denominators already for number 1. Number 1 looks a little easier, and in fact, it is. So let me just show you how to get this done. So let me give myself enough space here. Okay, cool. So let's check out number 1 here. All right. Does anybody here believe that to add mixed numbers, you got to turn both of them into improper fractions and then add them and then turn them back into a mixed number? Anybody here believe that that's the way to go? And again, be honest. Again, just want you guys to be honest. Who thinks, again, that to add mixed numbers, like these 2 right here, we have to turn both of them into improper fractions, add them, and then turn back into a mixed number? Okay, so the answer to that, false. Not necessary at all. So let me make sure I write this down at the same time that I'm doing it. So again, here, you do not need to convert mixed numbers to add them. You do not, okay? Do not need to convert mixed numbers to add them. Okay, I know I got in the way. My big old head got in the way. There it is. But let me just show you guys why this is true. Okay, let me just really explain why this is true, And I think I'm going to give everybody here a better sense of what mixed numbers actually really are, because mixed numbers are really just decimals. That's all they are. Mixed numbers are just decimals. So everybody, let me tell you this right here. In a nice little example, let me just go up here and just give some blank space. Let me preface this real quick, because again, I think this is really going to be worth it for you to really understand this as a really doable piece of math. So everybody, if I did this, if I said I had 1.2 plus, let's go ahead and say, let's go ahead and say 3 point, let's go ahead and say 3.7. Okay. Everybody, is it fair if I'm doing 1.2 plus 3.7, is it fair for me to be like, yo, let me just add the 1 and the 3 first to get 4, and then let me go ahead and add the 0.2 and the 0.7 to end up getting 0.9. Like, is that a valid way of doing it? Is that fair to do that? Like, is that a fair way of doing that? If I wanted to look at it that way, right? If I want, obviously you can look at that and be like, yo, you don't have to carry anything, so just do it. I get it. I know. I'm not talking to you, but I'm asking you if that's a fair way to do it. Okay, cool. So I see a lot of people are saying yes. I see a lot of people are saying yes. Let me now show you what I'm doing here. If I have 3 2/3 and 2 2/3, I can go ahead and say, hey, let me go ahead and add the whole numbers first, like I did over here. I can add the whole number parts first, add the fraction part second, and then see what I got to do after that. Watch this. Everybody, what's 3 plus 2? Help me out real quick. That's hard, right? That's a tough question. What's 3 plus 2? So 3 plus 2, that's going to give me 5. Okay. Now, really, all I have to worry about here, guys, all I got to worry about, let me use a highlighter here, is all I got to do is the 2/3 plus 2/3. So let me help myself out over here. Everybody, what is 2/3 plus 2/3? What's that going to give me? What is that going to give me? So what did I say when it comes to adding fractions? Everybody, when it comes to adding fractions, denominator changes or stays the same? Same, stays the same. That's right. We add the numerators, keep the denominator the same. So if I got a pizza box that has 2 out of 3 slices in it, and I got another pizza box that has 2 out of the 3 slices in it, if I add all the slices together, I'm going to have 4 slices out of a box that only holds 3. That's why you keep the denominator the same. My box only holds 3 pizza slices, but now I got 4 slices. So I'm looking at this and I'm saying, okay, cool. I got 4/3. Sweet. Everybody, do we have a particular skill here where we can turn an improper fraction to a mixed number? Do we have that skill right now? Do we have that skill? Oh, yeah, we do. Oh, yeah, we do. So let's go ahead and turn that into a mixed number real quick, everybody. 4/3. 3 goes into 4 just once. And then 4 minus 3, because again, divide and subtract. 4 minus 3 gives me a remainder of 1 out of 3. Everybody, what's going to happen if I literally grab this, put it right over there? Oh, look at that. Sorry, I didn't see you there, mister. There's already 5 there. And now we got an extra 1. Everybody, what's 5 plus 1? Yeah. We're going to add these back, and that's going to be 6 1/3. Not necessary at all to turn those into improper fractions. Not necessary at all. Our answer here is going to be A, but I do want to explain this answer again. So now that we've actually done the actual work, let me just explain to you what just happened. Because the traditional way that a lot of people have been taught is to kind of take more time than you need to by converting. None doesn't need to happen. What you can do, similar to how I did up here, notice how I added the whole numbers first, and then I added the parts. Right here, I added the whole numbers first, which gave me that 5 that I had down here. Gave me that 5 right there, okay? So put your pencils down, pay attention. I added the whole numbers first, and then I added the parts. It just so happened that adding the parts left me with an improper fraction. And so all I needed to do from that point was to turn that improper fraction into a mixed number and slap it back with the original number. That's all we had to do there. Just slap it right back. So Adam, before you say still lost, remember, Adam, we've talked about this. We've got to make sure we sit through the entire explanation to see what bits we can understand. And if you do still get stuck, which is natural, then we point out what part exactly got us stuck, all right? So we got to make sure we have that tenacity there. So again, step one, all I did here, let me just make sure I write this down. What I did was add the whole numbers. So add the wholes. Number two was, hey, let's go ahead now, add the parts or the fractions. And then step three, basically put them back together. And again, this is just a nice, simpler way to talk about adding mixed numbers. This is a nice, simpler way for adding mixed numbers. So if you want to take a picture of that, please do. Go ahead. Again, just a nice, simpler way of adding mixed numbers. That's it. That is it. And so, yeah, the 4/3 should have thrown us off, right? It should have absolutely thrown us off. But what we should have really rebounded with was, oh, wait, I could turn that into a more legible, like a more understandable way. And all that's going to be is just a mixed number. 4/3 is the same as 1 1/3. So we just added it back. Oh, 5 plus 1, that's 6. Done. So on the scale of no to yes, did that make sense to you personally? Adam, see, there you go. I'm glad it did. And so even if it didn't, again, be honest. Again, I'm not here to stroke my own ego. I want to make sure that you're taken care of, all right? So I think I saw Antonio say no. No worries there. I'm going to try to explain that again in the next problem and see what we get there. Kind of for Pedro. And the rest of us say yes, which is cool. All right, Joseph, nah. Maybe some more yeses. All right, cool. And so if you have 57 over 9, Jose, 9 goes into 57 6 times, right? And then the remainder is going to be 3 out of 9. 3 out of 9 is 1/3. So you should still have 6 and 1/3, Jose. Should still have 6 and 1/3. Yeah, all of those methods. Yeah, okay. You remember, more than one way to do math. Absolutely. Absolutely more than one way to do math. So let's take care of number 2 here, my party people. Let's go. Number 2, we have half plus 3 and 1/3. So everybody, are there whole numbers to add here? Are there whole numbers to add? Nah, there isn't, right? Like if I wanted to apply that same strategy, I couldn't. I can't. There is no whole number in front of the half. So doesn't matter. Still do it. Nothing plus 3 is still going to be 3. You're fine. You're fine. So that was step 1. Add the wholes. There's only a 3 there. And really all this is doing for us, guys, all this is doing for us is removing anything that doesn't need to be there. That whole number 3, don't worry about it. Put it off to the side for a second. Just put it off to the side. It's not going to affect the problem right now. Now the next step is going to be, 1/2 plus 1/3. This is the next part of the problem. So I'm going to take this here and say, hey, I've got 1/2 plus 1/3. Everybody, what is the problem? What is the problem right here? What's the problem? There we go. That's right. We have different denominators. The bottoms are different. The bottoms are different. So remember, we need the same denominator. We have to have the same denominator because if not, then we can't do it. You can't add 2 boxes of pizza together when the slices are different size. That's not going to work. Not going to work. And so we have to ask ourselves, hey, what can 2 and 3 both go into, everybody? What can 2 and 3 both go into? This is called the least common denominator, okay? So let me change this up here. We need the least common denominator. This is what we need here. Least common denominator. If you are anywhere near confused here, this is where you need to start taking notes. We need to find the least common denominator, which is the same thing as LCD, of 2 and 3. We have to find that least common denominator between 2 and 3. And literally all that means, what can they both multiply into? What's the smallest number, the least number that they can both multiply into? 2 and 3 can both go into 6, okay? They can both go into 6. And so how are we going to play this? The way that we're going to play this is, hey, what do I have to do? Everybody, what do I have to do to 2 to get 6? What do I do to 2 to get 6? How do I go from 2 to 6, Danielle? That was quick. That was close. But not divide by 3, but multiply. Yeah, hey, we're going to multiply by 3 here. Going to multiply by 3. And what was that one cardinal rule about fractions, everybody? Whatever you do to the what, do the what was that again? What was that? Exactly. Whatever you do to the bottom, you do to the top. You got to make sure we're consistent here. We got to be consistent. Remember, what you do to the bottom, you do to the top. You got to be consistent. And so here, you got to multiply by 3 on the top and the bottom. Adam, I'll take your question in a moment here. I got you. And then also with the 1/3 over here, we're looking at the 1/3. All right, I'm trying to get that 3 to be a 6. Everybody, what do I multiply 3 by to get 6? Okay. And whatever I do to the top, I do to the bottom. Sounds good. And so with that said, there it is. And so let's just slowly write this out here. Let's slowly make sure we're good. That 3 is still off to the side over here. So let me go and grab this. This first one, I'm going to grab it. And 1 times 3 is 3. 2 times 3 is 6. I'm going to grab the other one here. I'm going to use green to grab it. And there, I'm going to have 1 times 2 is 2. 3 times 2 is 6. And everybody, what operation was happening again? Help me out. Was it adding or subtracting? Right, it was adding. It was adding. It was adding. We're good. Can we now add these? Can we now add these? Right, we absolutely can, absolutely can, absolutely can. And so we will add these and we will get 5 out of 12, right? 5 out of 12, yeah, yeah, yeah. Come on, give me a yes. 5 out of 12, right? Nah, exactly. It's going to be 5 out of 6. 5 out of 6, 5 out of 6, 5 out of 6. Keep the denominator the same. And so we found our result there. Everybody, what do we do with that 5 out of 6 again? What do we do? That's right. That's right. Bring it back together. Exactly. Attach it back with the whole. And so we have this right here is a 3. We have our fraction there, the 5 out of 6. And so our answer becomes 3 5/6. There is our complete answer. And that's why B is it. So again, we did the same thing though. We added the wholes, added the fractions, and we put them back together. That's exactly what we did, everybody. We added the wholes, added the fractions, and brought it back together. This is a similar strategy to splitting and gluing for mental math, where you split apart by the units, the whole numbers, split them and add them. Okay, then the fractions, add those together, and then we're good. And so no, Mario, there is not a 1 in front of the 3/6. There is not. There is not. Because that is literally saying 1/2. Not 1 1/2. No. Just half. And so I'm going to give you guys the room here to take a screenshot because we're going to practice this again. We're going to try this again. We got 2 more problems here. We're going to try this here. So Adam, let me take your question, boss. Let me go ahead and give you the mic if you want to ask your question with the mic or with the, oh, I see you typed it out. Before you do any work, you really have to do all that because the remainder is 3. However, there is no other remainder with 3, so that I think you're reaching for a coincidence there, Adam. Let's go ahead and let's try this out here with these next couple of problems. If that still holds true, you might be onto something. But let's not make assumptions when there are not any to be made, all right? So any questions before we move on to the next set here? We're going to have 2 problems here. I think I might extend it to 2 minutes now that we know how to do these. I want to extend it to 2 minutes to see if we can get both of these done in 2 minutes. So with that said, going once, going twice. All right, silence is compliance. Sounds good. 3, 2, 1. Let's go, my party people. 2 minutes. Let's go. So here we go. Let's go ahead and start off here with number 4. This one's going to be a little easier to take care of. We've gone over this. We can do this one a little easier. So we have 1 3/8 and 4 2/3. We're going to add these together. Now, the reason that I'm pointing out the addition problem first is because, again, the addition is going to be a little bit easier because all you have to do is, hey, let's take these whole numbers. Let's add them together. Everybody, if I take the whole numbers, 1 and 4, 1 plus 4 is going to give me what? Right, 1 plus 4 is going to give me 5. So I'm going to teach everyone here a very, 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 very important lesson when it comes to test taking. I'm going to tell you right now that just based off of that, I know what the answer is. Everybody, the answer here is going to be D, 6 and 1/24. I know that that's going to be the answer automatically. You want to know why? Well, everybody, we know that the 1 plus the 4 is going to give me the 5. But everybody, is it possible to add 2 decimals, like 2 numbers that are less than 1, and then get up to 9? Is that possible? No, there's no way. There's no way. No way. No way at all. Like, honestly, that could be a whole 2. Like, you could change that fraction to make it a whole 2. You could change that to make this whole thing 5. 2 plus 5 is at most going to be 7, and there is no 7 here. I know it's at least 5. Can't be bigger than 7. There's my answer. Did I just blow anybody's mind or kind of give anybody a moment? So I really want to point that out because, again, on the ASVAB, it's not about, showing your work and all that. No, it's about getting the right answer. More than one way to do it, especially when you have multiple choice options. You got to go ahead and kind of bring your eyes up real quick, analyze the situation before you do. But obviously, we're here to learn how to actually do it as well. So let's go ahead and go through the explanation. But again, boom. And the reason, Mario, that they can't be more than 7 is because I'm saying 1 plus 4 is 5. If that was a whole 1, and if that was a whole 1, the most it could be is 7 when you add it back to the 5. That's the most it could be. So there's no way it could be 9, right? And we know it's already more than 2. So we're good. Yeah, so that's the idea there, Mario. You're good. So Adam, let's go ahead and go through the problem here. So we have 1 3/8, 4 2/3. We added those whole numbers together and we got the 5. So that was step 1, add the whole numbers. Now what we're going to do is we're going to add these fractions now. Let's go and add those. So we have 3/8, and we're going to be adding that with 2/3. Everybody, can we add 3/8 and 2/3 right away? No, we absolutely cannot. Absolutely cannot. And so we have to ask ourselves, what is the LCD? What is the least common denominator? Least common denominator, LCD. What is the least common denominator between 8 and 3? What can they both multiply into? That's a small enough number here. Yeah, I love it. I love the participation there. Yep, it's going to be 24. It's going to be 24. And so let's write this out here. The LCD, let me use a different color here. And let's use whatever, blue. So LCD of 8 and 3 is 24. You can do 8 times 3. That's going to give it to you right there. It is 24. So we're checking that out. We got 24. So that's our goal here. Turn these fractions into a denominator of 24. So with that said, let's go ahead and ask ourselves, my party people, what do we do? What do we do to 8 to get to 24? What do we do to 8 to get to 24? Thanks, Anthony. First one there. Appreciate that. And yep, Mons, Ronald, Adam, Marie, Joe. Alexandria, Antonio, Peggy, absolutely. We're going to multiply by 3. Now, whatever I do to the bottom, got to do to the top. Got to do to the top. We're going to multiply by 3 up there. And so what that's going to turn us into here, 3 times 3, that's going to give us 9. 8 times 3, 24. Now, let's take care of the other part here. Taking care of the other part. How do I go from 3? How do I go from 3 to 24, everybody? That's correct, my party people. Yep. Multiply by 8 in the numerator and denominator. And so 2 multiplied by 8, that's going to give me my 16. 3 multiplied by 8, that's going to give me 24. And so if I add these together, everybody, what's 9 plus 16? What's that going to give us? What is that going to give us? Nine plus 16. What's that going to give us? Yeah, that's going to give us 25. And we have to keep the denominator the same. Absolutely. So that's going to give us 25 out of 24. And so we have to ask ourselves, oh, whoa, that is improper. We cannot write the answer as 5 and 25 over 24. That makes no sense at all. Like, that's like saying, hey, I want you to run 1 3/2 miles. Bruh, no, that doesn't make sense. I want to slap you for saying that. Honestly, that's not going to make sense. So we're going to need to actually turn this into a mixed number and then bring it back. The great thing about this is that how many times does 24 go into 25? Right? That's the great thing about this. It's only going to be a 1. And what's left over? Right. That's going to be 1 out of 24 left over. And so what we're going to do is we're going to take this right here. We're going to take that right there. And we're going to bring it back with the 5. So we have a 5 right here. Bring back the 1 and 1/24. Everybody, what's 5 plus 1? Yep, that's going to be 6. And that's going to be 6 and 1/24. And boom. There you go. So am I going to sit here and tell you that this is the only way to do it? No, I'm not. You can absolutely take both numbers, turn them into improper fractions, then change the denominators, then add them, and then turn it back into a mixed number. But look at how many steps I just spewed out. What if we could do it in smaller steps? And that's why I'm showing you what I'm showing you here. It's not always going to be about getting the right answer. It's about how quickly you can get the right answer. That's what this is about. So does anybody here appreciate what I'm trying to do here in explaining this? Or is anybody here like saying, nah, like this is a complete waste of time. Like I know what I'm doing, or my way I know is definitely better for me. Like, be honest. Okay, so I didn't see any very helpful. Okay, cool. Just making sure that I'm not wasting my breath here saying that. Now, I want to go over this last one here, the subtraction problem. Now, unfortunately, we did have a great time, but I want to make sure we can get through at least this last one here, and then we can go ahead and wrap things up, all right? So stick around here, and just as a reminder, if you do like what you've been seeing here, if you feel like this class is something that you'd like to get into with the recordings and more things like that, stick around to the end. I'll introduce my all access pass. Super easy to sign up. It's actually way cheaper than anything you'll ever find. So I'll explain that in a moment here. So let's talk about number 3 here. This one is definitely going to be a little trickier to understand. So when it comes to subtraction with mixed numbers, honestly, if you wanted to go ahead and turn it into an improper fraction, then subtract and do your thing, cool, you're good. But my number one suggestion, every single time that you're going to be messing around with subtracting mixed numbers, change the denominators first. All right. That's always going to be my number one piece of advice when subtracting mixed numbers. So let me write that down here. Let me write that down for you. Makes life easy. Subtracting mixed numbers. Step number 1, always change denominators first. Because whether you want to turn it into an improper fraction, then subtract, or use the technique I'm going to show you, neither of them can work unless you have the same denominator first, okay? That's the idea. That's the idea. So let's go ahead and get to it here, my party people. Everybody, let's ask ourselves, what do 4 and 7 have in common in terms of a common denominator? What can they have? All right, they both go into 28, and that's the smallest number that they both go into. So with that said, let's go ahead and change both of these to a denominator of 28. So let me zoom out just a little bit here. And so let's get to it. So we have 3 and 1/4. And so 3 over 7 over here. Everybody help me out. What do I multiply 4 by to get to that 28? Right, it's going to be a multiplier of 7. That's right, multiplier of 7. And I'm going to do that to the top as well, bringing me to 3 and 7 over 28. Sounds good. Next, I'm going to subtract from that. And we need to make sure that 3 over 7 turns into a denominator of 28. And that's going to be multiplying 4 on the numerator and that denominator. So we're taking a look. All right, cool. We got 3 multiplied by 4. Hit me, everybody. What's that going to be? Right on, my party people. That's going to be 12. And then the 7 times 4 is aptly going to get us 28. That's what we wanted. Okay. So I'm taking a look here. And this is where a lot of us may be looking at this saying, I don't like that. Anybody here looking at that saying, I don't like that? Right? Doesn't really make too much sense, right? You're looking at that like, what? So if you've been to my previous classes, this is, I'm gonna blow some minds real quick. This is my strategy here. Everybody, let me ask you this. When you're subtracting, aren't you just taking the difference? Aren't you just asking like how many numbers are between this one and that one? Isn't that all subtraction is? Okay, cool. Everybody, put your pencils down for one moment. If you stay to the end of this class, you are in for a treat. This is actually not as hard as you might think. So I'm going to try to explain this in 2 different ways. Whichever way you like best, great. If you didn't get it at all, don't worry. I will eventually make a YouTube video out of this one, and I'm going to help you all out. But let me just give you guys a little treat here. I'm looking at 3 and 7 over 28 minus 12 over 28. I'm looking at this like, yo, this sucks. But here's what we can do. Everybody, what is the difference between 7 and 12? How many numbers apart are 7 and 12? Right. But is that a positive 5 or a negative 5? If we're doing 7 minus 12. Because if you do 12 minus 7, that's 5. 7 minus 12, that's negative 5, right? So guess what, everybody? All that negative 5 means is this. What happens when you do 28 minus 5, everybody? Take away that 5 from the whole number. Take away 5 from 28. What do we get? What do we get? Take away 5 from 28. What do we get? We get 23, right? Okay, guess what? You guys remember how when you're doing subtraction regularly, if you are subtracting more than you have, what do we always do? We always what? What's that B word? What do we do? What do we do? Yeah, we borrow, right? When we're subtracting more than we have, we borrow. And that's exactly what we're going to do here. If we got 3 and 7 over 28, minus 12 out of 28, 7 minus 12 is negative 5. So if I take away that 5 from 28, I got 23, but I got to borrow. So my answer, not 3, but 2 and 23 over 28. All we did was borrow to get that done. That's one way of looking at it. I'm going to show you another way here. I'm going to show you one way, but that's one way of looking at it. Yes or no? Does that make any sort of sense at all? Does that actually make any sense? To get 2 and 23 out of 28. Yeah, perfect. Now, let me show you the other way here, because I know that not everybody's going to agree. Not everybody's going to be perfectly like ready to go. So let me show you the other way that you can still think about this. It's still from the idea of borrowing. Because here's the thing. I don't want anybody here turning this whole thing into an improper fraction. It's just not necessary. It's not. So what you can do this, everybody. If I borrowed 1, so if I turn that 3 and 7 out of 28, if I turn that into 2 and 1 7/28, I can turn this into an improper fraction. Just turn that one into an improper fraction, because all you have to do here is this. 1 times 28, 28. 28 plus 7, that gives me 35. And so I can actually say that this right here is 35 out of 28. And I'm subtracting this right here, 12 out of 28. So if I were to do that, everybody, what's 35 minus 12? What is 35 minus 12? What's that going to give me? 35 minus 12 is going to give me 23. So that right there is going to end me up with 23 out of 28. But everybody, what did I forget earlier on? What did I forget? That's right, Adam. I forgot the 2 right there. I forgot the 2. And so by borrowing, we can get a problem like that done. Again, there's 2 different ways of thinking about it. There's actually 7 different ways that I can think of off the top of my head, but I don't want to, exhaust you with all these different methods. All I'm trying to prove to you is that if we're trying to go ahead and use mental math, all mental math relies on, it relies on those rules that we already know, but we use them to split a big problem into smaller, easier pieces. Yes or no, everybody? Does that make sense? Even if we didn't totally understand this, do you understand the idea of mental math as a way of, again, breaking down something complicated into trying to understand it in smaller, easier steps? That's really where I want to get at with this. I will be making a YouTube video out of this because I know that we were doing this at the last second. So obviously it's fair that if not everybody gets it. So I'm going to do my best to make a video for this. It'll be coming up soon. This week we have the word knowledge lesson video that I'm putting up, but next week we have a fractions one, and I think I'm going to put this one in there. Okay. And so the 23 out of 28 just shows up right here, exactly like it did before. But long story short, my party people, the answer to number 3 is going to be B, and the answer to number 4 is D.